First, we need to find the pressure exerted by the concrete onto the formwork while placing. In order to do this, we pull the following equation. Our value of P max, our maximum pressure in kilopascals, is going to be 30 times CW as our lower bound, and then calculated as CW times CC times a empirical equation that's 7.2 plus 785 times the pour rate divided by the temperature of the concrete in degrees Celsius plus 17.8. And this is bounded by the upper bound of rho GH, which is just going to be the pressure if it was a perfect fluid. So if this was just water and it was completely fluid, we'd use rho GH to get our pressure at a certain depth. Now, using this equation, as you'll notice from the material I'll paste below, is there's a couple options. And the reason we use this equation is because of the following assumptions. We assume that the slump is less than or equal to 7 inches from our table of typical slumps. And this is reasonable because the typical slump for our application should be between 1 and 4 inches. The column should be filled to a depth of 1.2 meters or less. Technically, the stage 2 concrete that we are placing is 1.3 meters tall in the end, but it is first filled until 7.5 centimeters from the top of the formwork, and this is going to be less than the full 1.3 meters. So it's at least 1.2 meters, but likely more around 80 or 90 centimeters. Third, this equation is SI units. And finally, our pour rate, has to be less than 2.1 meters per hour. And thinking about this logically, we can take our pour rate, R, as a conservative 0.5 meter per hour. So considering that we can fill a single tower in about 1 hour. 2 hours of placing concrete with buckets. CW is our unit weight coefficient from table 49.4. And using our concrete unit weight of 2,400 divided by 2320, which is the value given in the to calculate the CW coefficient, we get a value of 1.034. And then our CC is our chemistry coefficient, and this is read off table 49.5, and based on our type of cement is taken as 1.0. We'll conservatively take our concrete temperature at placement of 5 degrees C. If you notice from the equation, a lower temperature value is going to increase our pressure. So 5 degrees Celsius is pretty low and is a good limit to choose to start with. Finally, we can calculate our Pmax value, and we'll notice that the minimum is going to be what governs that CW times 30. So we'll take 31 as our minimum, 31 kilopascals as our Pmax concrete pressure value on the formwork, and we can move on to evaluating the actual formwork strength and if it can resist this load.